So the topic is about the chemical kinetics. What is chemical kinetics? It is a branch of a physical chemistry which deals with the rate of a reaction, that is called the chemical kinetics. So in chemical kinetics we are going to discuss about the rate of a reaction. So when a reaction takes place, at how much speed this reaction has taken place, that speed we will note, that is about the rate of a reaction. So what is chemical kinetics? It is a branch of a physical chemistry which deals with the rate of a reaction, that is the chemical kinetics. And normally a chemical reaction takes place in a spontaneous it is a spontaneous reaction. Chemical reaction is a spontaneous reaction, and we write from the left to the right till all the reactants will be converted into a products. Okay, and this spontaneous reaction is of fast and of slow. Okay, fast reaction we can take example of when an aqueous solution of AgNO, that is silver nitrate, is added to the aqueous solution of NaCl. What happens? There will be a fast precipitation of AgCl is formed. Okay, so this is a fast reaction. AgCl precipitate will be formed. Okay, next in slow reaction, when rusting of iron is takes place over years, this is a slow reaction. Okay, the spontaneous reaction, it may be slow or fast reaction. Fast reaction, when example AgCl precipitate will be formed when AgNO3, that is silver nitrate, when it is added to the aqueous solution of sodium chloride, that here N will be capital Na. Okay, so this is about the chemical reaction. So in chemical kinetics, what we are discussing, we are going to talk about the rate of reaction, rate law, and what are the factors which influence the rate of a reaction, and the sequence of steps which occurs in a reaction. So next, reaction rate, we can call it as a reaction rate or rate of a reaction, same. Okay, so here if we take A is a reactant here and B is the product. So A is a reactant, B is a product. So in concentration terms, if we see of a reactant, the concentration of a reactant A will be decreasing and the concentration of a product, that is B, is increasing. So there is in the change in the concentration. So how can we define a rate of a reaction? The rate of a reaction can be defined as a change in the concentration of a reactant or product as the time passes. Okay, so as the time increases, there will be decrease in the concentration of a reactant, increase in the concentration of a product. To understand, just I kept like circles. See, it is in terms of concentration. So what happening here in A, concentration is slowly it is decreasing and the A get disappears and the product B will be available. Okay, so we can write it as rate of reaction is equals to rate of disappearance of A. So A get disappears and rate of appearance of B, we get the product B. Okay, so we can write it as, the equation is like minus D, the concentration in brackets will write down minus D and by dt. Okay, so minus indicates that the decrease in the concentration. Where is the decrease in the concentration? The decrease in the concentration is in the reactants. So in the previous we have seen A is a reactant. So in that reactant the concentration is decreasing. So we are mentioning it as minus D. In brackets we can write down A by dt. Okay, minus dA by dt. That is a reactant concentration. Next, coming to the product term, we can say the concentration is increasing. So we are indicating it here plus dB by dt. The product concentration is increasing. So we are mentioning here plus dt by plus dB by dt. Okay, so the the units of the rate of a reaction are concentration, we can take it as mole per liter. Okay, so time we can time we can say that it can be in seconds or in minutes or in hours or in days also we can take. Okay, so then we can say the units of rate of a reaction is mole per liter second or mole per liter minute or mole per liter hour. Okay, so here once see, we can write it as in mole into liter inverse second inverse. So mole per mole into liter inverse minute inverse also we can write like that. So unit of a rate of a reaction is mole per liter second, mole per liter minute, mole per liter hour. This is about the units. Next, coming to see, just to know an example of concentration of carbon monoxide. As the time increases, as the concentration will be decreasing. That example I have mentioned here. So when a carbon monoxide is reacted with the nitrogen dioxide, what happening here? It forms a carbon dioxide plus nitrous oxide. Okay, we are taking only the concentration of the carbon monoxide. We are checking the concentration of the carbon monoxide as the time passes. So when we take it for every 10 seconds, first the concentration of the carbon monoxide was 0.100, okay, at 0 seconds. And after 10 seconds, if we see, the concentration of the carbon monoxide is decreasing, that is 0.60, 0.067. okay, so likewise up to last at 40 it was 0.033. okay, so we can say that starting it was decreasing very rapidly, the concentration was decreasing very rapidly. At last at 30 to 40, if we see, there is only small difference is there, 0.0402 to 0.033, there is small difference. So as the time passes, the decrease in the concentration is decreasing very rapidly. okay, that is about the concentration of the carbon monoxide. Just an example. So we can plot it in a graph. Like initial, if we see the initial difference, it was 0.033. At last difference was at 0.007. First 10 seconds it was taken, and the last 10 seconds it was taken, that is 0.007. that is about the concentration of the carbon monoxide. So we are discussing about rate loss. So how we will write? Rate is directly proportional to the concentration of a reactant. So rate is equals to, when we remove the proportionality, we take constant K into A. okay, A reactant. okay, so this is the rate law. Here we will write like this. okay, in brackets we are writing. So if a reaction is given here, H2 plus I2 is given in the terms of rate law. How it is given? So H2, it is kept in brackets, and I2 also kept in a bracket. Likewise 2NO2 is written in the form of NO2. Here 2 is kept in a power form. okay, 2 is kept in a power form. So now this rate law written, how to write is like this, rate law. So rate is equals to K into A. Next, order of reaction. The order of reaction is defined as the sum of power of concentration in the rate law. For example, if we see in the above, 2NO2 is written as NO2 in brackets, and the power, in the power we have written 2. So 2 means the order of the reaction is second order reaction. So example also here it is given. The powers we are adding, which gives the order of reaction. The sum of powers give the order of reaction. That is about the rate law and order of reaction. So reaction order and order of reaction both same. So by the rate law, if we write like this reaction order, we can say the first order, second order, third order reaction. That is about the reaction order. And molecularity of a reaction. So molecule, if the same molecule, see these chemical reactions based on the molecularity of reactions, they are of two types: elementary reaction and the complex reaction. See, elementary is the simple, it occurs in a single step, whereas in the complex there may be few steps will take place in the complex reaction. See, only if a one type of molecule is taking place, we can say that is a unimolecular. When two molecules are taking place in a reaction, we can say that a bimolecular. When three molecules are taking place, we can say that it is a termolecular. So example of the unimolecular, see, just example, A gives a product. So here only one molecule is taking place in a reaction, so it gives a so it is a unimolecular reaction. Examples: bromine. to bromine. So that is about the unimolecular. Like A plus B gives the product. Here A one molecule and two another molecule. These two molecules giving a product gives the bimolecular. Intermolecular reaction, three molecules taking place, we say it as a thermomolecular reaction. So examples are given. So this is about the molecular of a reaction. So if we see the molecularity and the order of reaction, when we compare it, see in reaction A, it gives a product. First one, A gives a product. How many molecules are there here? Only one molecule. So it is unimolecular. So molecularity is 1. And in rate law, how we will write? Rate is equals to K into, in brackets, we write down the reactant, that is A. So A to the power, so if nothing is there means 1, we will mention it as 1, that is the first order reaction. And next A plus A, how many molecules taking place? 2, A and A, 2 molecules. So molecularity is 2. So how we write in a rate law? Rate is equals to K into A. So 2 is there by, so power, in the power we are writing 2. So it gives the second order reaction. Whereas in A plus B, here also same, A and B, 2 molecules are present. So 2 molecularity is 2. So A in one bracket, B in one bracket, it gives 1 plus 1, A to the power of 1, B to the power of 1, 1 plus 1, the sum of 2 will give the 2. That is the second order reaction. Next A plus 2B. So it gives a product. And how many molecules? 2 B's and 1 A. 2 plus 1, 3. Molecularity is 2. And rate is equals to K into A and B. Here side the number we are writing in the power form. So B whole 2 is there. So A to the power of 1 and B power 2. 2 plus 1 is 3. So order is 3. That is third order reaction. So in molecularity, we will see how many molecules are reacting, and in order of reaction, we are seeing the power, sum of power of the concentrations we are taking, and we are mentioning it as order of the reaction. That is about the difference between the molecularity and the order of the reaction.